machine program, and this will be similar to what it looks like. I think we'll be able to add some graphics, and I believe I had a version that had a payout where when you win, like coins would come flying out of the machine, like down here, and you'd see like these coins tumbling down in the graphics. I just need to go through. I have so many versions of this. I have to go through and find the one that actually works. But we're not going to get that far today. Today what we're going to do is we'll get this model here on the screen, and we'll have these dials, but we won't have the graphics yet. We're actually going to make numbers. We're going to start with numbers, get those to work correctly, get the timing mechanism to make the numbers roll and stop and all that. And then we will add the graphics later, and then also probably either next week or the week after that, we'll start adding the Python logic that actually determines whether you win or not and how much you win based on what combination is on the screen. So when I program a game like this, or when I program something in general, it's usually really helpful to try to envision the program like a mechanical device and try to understand what's happening in that mechanical device and use those pieces of the mechanics, kind of emulate those in code, especially when you're physically making a mechanical device in software, right? So it's often a good exercise to, especially if you're trying to emulate something that actually exists, like a slot machine, to talk about or to think about how a slot machine actually works, what the gameplay is, what the steps that are involved in playing a slot machine, and then think about the mechanics that actually happen for that gameplay to occur. So let's talk about real quick, like, how does the gameplay on a slot machine work? When you are going to play a slot machine, what's the first thing you do, and how does the machine respond? So what do you do when you want to play a slot machine? What's the first thing you do? You put a coin in, right? Because it's not going to play for free. So in our game, we'll probably make it play for free, but we'll eventually add a bank where you have to have money in the bank to be able to pull the handle. And if you have no money in the bank, it'll say you'll need to add money to the bank before you can play. So you put your coin in. Then what's the next thing you do?
Pull the lever.
Yeah, you make a betting selection if it's a multi-line machine. This is a much simpler version. We're only analyzing one line, so there's not multiple betting modes. There's only one betting mode, and it just costs what it costs, like $1 or 1 credit or whatever. And then, yeah, you're right, you pull the handle. Then what happens after you pull the handle?
There's a function on the machine, a system of gears that create a timing at which the different wheels with pictures, imagery, numbers turn.
Yeah, so the wheels spin.
Yeah.
Right. So then the wheels spin, and then what happens with the wheels once they're spinning?
There are usually a number of wheels.
Yeah.
They spin at they start at the same speed, but they stop in different time.
Yeah. So then they stop. And do they stop all at once, or do they stop one at a time? Yeah, they stop 1, 2, and 3 usually, right? And like I think what he was implying is that what Chasen was implying is that there's mechanics in there that varies the speed and the timing at which they stop, such that it's a random event, or at least you're meant to think it's a random event on where the position of those wheels will stop, right? Yes.
Putting that function in, that would be the Python code.
Yeah. So, a lot of that actual mechanics are going to be just handled through actual operators inside of Touch Designer without having to do a lot of Python code. But we will be creating associations between Touch Designer operators using some simple Python, and then the actual logic where it looks at what order of numbers you have or what orders of symbols you have and determining whether that is a win and how much money you would get if it is a win. That will be mostly in Python. But yeah, question.
Is the slot machine itself like a template that designer already created?
No, I have content I can give you. This is a 3D model.
Yeah.
So I downloaded something from 3D Warehouse, and I edited it to make it like I took a slot machine model from 3D Warehouse, and I pulled out the wheels from it so that there's empty slots there, so that we can add our own physical wheels inside Touch Designer.
Very cool.
Yeah. So we'll look at that in a second. Okay, so wheels spin. We're talking about the order of gameplay on a slot machine. So you put your money in, you pull the handle, the wheels spin, the wheels stop one at a time in random places, and then what happens? You win or you lose, right? The machine determines whether you win or whether you lose, and then if you lose, what happens? What? Yeah, you'll lose money, right? Really, actually, you lose money as soon as you pull the handle, right? So nothing happens if you lose. If you win, what happens?
Get more money back.
Yeah, it determines how much you win based on what 3 symbols lined up. In our case, I have a whole like payout scheme that I figured out based on some old fruit machines, and I made the executive decision that all 7s is the highest payout. So that's like the jackpot, and then like all bars or something is the second highest, and then there's a few combinations that'll give you a little bit of money for 2 of them lining up, and the third one being a bar or something like that. I don't remember it off the top of my head. But we're not going to get there this week. But yeah, so there's an analysis of what the win state was, if there was a win state, and how much money you get out of that. And then what happens then? Then the coins drop down if you win, right? So there's an actual like payoff, right? In our case, we're not going to be able to dispense coins out of your laptop, right? We're not going to be able to give you Bitcoin or anything like that. But we'll at least have a visual payoff that won't happen every time you play. That'll make that win state more exciting. Like, do you guys ever play? Did you ever play Solitaire on like Windows 95? And am I dating myself, or does anybody know what I'm talking about?
Yeah.
Yeah.
When you get all the cards, those cards like would bounce across the screen. I used to love that so much. Like, that was like the reason why you played, was because you wanted to see those cards bounce across the screen. If they had just given you an option of hitting a button and making the cards bounce across the screen, you probably would never play the game, right? So that will be our like coins tumbling out, and maybe if we probably won't have time, but if you wanted to, we could probably figure out how to like make fireworks explode, or a video play saying you're the jackpot winner or something like that, to make that payoff be something that makes you want to engage with the game, right? So that's the gameplay, like the what happens when you engage with this game. But we can try to figure out how to actually code that by thinking of the actual mechanical device of a slot machine. Now, technically, a slot machine in Vegas today, they make you think it's a mechanical device, but it's really just a computer program, just like we're doing here. The slot machine itself pays out a certain percentage, and whether it's going to pay out when you put the coin in is determined on how much it's paid out before you even played. And there's a percentage that the Nevada Gaming Commission and the slot machine and the casino have agreed upon is a fair payout scheme, and it's only ever going to pay out that percentage. So the casino will always make its money, even if they're giving you money. Over the life of the machine, even if you get a jackpot out of that machine, nobody's going to get a jackpot from that machine for a while to make sure that that machine is paying out the exact percentage that they agreed to pay out. And they make you think that it's a mechanical device by having these physical wheels that are spinning, and those wheels might have varying speeds and might stop in an unpredictable pattern, but really, as soon as you hit the button, the computer has decided what your outcome is going to be and makes those wheels spin and will stop them exactly when the computer says they should stop. But previous to that, like machines from the 70s and earlier, maybe the 60s and earlier, I don't know when they started doing computerized machines, it used to be an actual randomized mechanical device. And the way a slot machine in the past has worked is when you pull the handle, after you put your coin in, when you pull the handle, there is a kicker device that when you pull that handle down, you're engaging a spring. That spring kicks the three wheels, and there's a randomized clutch mechanism in there that varies the amount of torque on each of those wheels, and then when it kicks the wheels, it will change the torque for the next time that the game is played, so it's not predictable how much torque, how much friction is going to be on that wheel. So that's one area of randomization. The other area of randomization is as it's spinning, there's like a fan blade in there that is picking up friction from the ambient air pressure in the room, which changes. So that makes it hard to predict, how far that wheel is going to spin. And so then the kicker kicks the wheels, they start spinning with different torques. And then there's this grabber mechanism that starts inching its way up, and it has 3 teeth, or maybe 4 if there's 4 wheels. And those teeth are different lengths, one like this length, one like this length, and one a shorter one. And as those come up, it stops this wheel first, then it stops this wheel, and then it stops that wheel. And because of the randomized speed of those wheels, and the randomized friction on that grabbing device from the fan blade, the time that it takes to stop those wheels is random. So you can't effectively get a pattern where okay, based on this wheel, and this wheel, the next time I pull the handle, there should be an 80% chance that it's going to win. That the whole device is designed to thwart that kind of analysis by the player, right? So what do we have to do to create a slot machine? We need a slot machine body, and that's what we'll start with. We need 3 wheels with symbols on them. We're going to start with numbers. We need those wheels to spin. Then we need a randomized speed for those wheels to spin and a randomized timer that stops the wheels. Now, it's not completely random. We want the wheels to spin at a speed that is interesting to the player. We don't want it to spin so fast that we can't read or see what symbols are on there. We don't want it to spin so slow that they think the game is broken. We want the time to be an engaging amount of time before it stops. We don't want it to stop instantaneously after they start spinning, and we don't want it to take 30 seconds to stop because then we won't get enough plays in. And we want them to stop wheel 1 first, wheel 2 second, and wheel 3 third, so that it builds some anticipation in the player where they get the first 2 to match and that third wheel is still spinning. They're like, oh my God, I might win. And even if they don't win, you've built up that anticipation, and that's kind of a psychological hook that will help them want to play the next time, right? Whereas if it was just all 3 of them stopping on a random order right after you hit it, you would get discouraged with the game really quickly when you didn't win, and you'd stop playing, right? So it's building up that anticipation in the player. That's what keeps them coming back for more, right? All right, so let's see. Let's go to the website and download some content. So go to week 5, and if you click on the link here on the description of week 5, you'll go to the subpage, which has a recording from last year. I will change that recording with the recording that I'm making right now, and download these documents, these files. I don't know that I actually need this aluminum stuff. I think I did that to color the housing of the thing. But we definitely want this lucky slot, the slot machine.obj, and the slot symbols files. So download those. And then let's go ahead and make a new Touch Designer file. And because we are doing some Python coding in here, I think it's probably a good idea to save often, because sometimes your Python coding, if you write it wrong, can crash Touch. So save often. So let's go ahead. Once you get your Touch Designer patch loaded, get rid of all the content that they give you at the beginning. We don't need any of that. And then File, Save As, and call this slot machine. I'm going to call mine, because I have multiple versions, I'm going to call mine slot machine class 2020, but you can call yours whatever you want. Save it in some place that you'll be able to find it again. Okay, I'm going to close the palette browser to give myself some more screen real estate. That's this up here. We won't need to use that much at all in this course, so I almost always close that palette browser. Okay, have you guys all downloaded the content from the website? Cool. So find the slotmachine.obj. And when you find that, why can't I find it? Slotmachine.obj. What? It was here? Oh, right there. Just drag it from a Finder window or from your Windows Explorer. Just drag it right onto your onto the canvas on Touch Designer, and you should see this thing pop up. It'll automatically create the SOP for you and populate this. It's a little bit weird offset to the right. I think that had to do with the original 3D warehouse file, but it doesn't actually matter. When we start rendering this, it'll be right in the middle of the screen. It's only this view that's a little bit offset for some reason. I'm not sure why. Let me pull out my notes before I get too far behind. Okay, so we have this, and if you want to take a look at it more closely, you can make the viewer active, and then you can drag around and look at this thing. You can zoom in, and if you look closely, it's a little hard to tell, but it's basically a flat shaded slot machine with 3 wheel housings, but no wheels in those housings, because we're going to create our own wheels. So let's see, let me pull my notes out. So the first thing we're going to do, that's week 4. I want week 5. Go away. No. Shoot. Week 5. Here we go. Okay. So the first thing we need to do is create those wheels. And what kind of shape would you do for a wheel? For a slot machine wheel? A cylinder, right? You would think that there is a cylinder in the SOPs, but there's not. There's not a cylinder. What? You can, or you don't have to. You can turn it off if you want. But there is, they have to be different. They just call theirs a tube. I don't know why. No, who calls a cylinder a tube? Yeah, yeah. Right. Yeah, they just want to be different, right? So first of all, if you make the viewer active on the tube here, you can see it's like a tube. It's a hollow cylinder, right? We probably won't see the sides of these cylinders, but maybe if you move the camera too far over, you might. So we actually want them to be a solid cylinder without being able to see inside of it. And there's an option here called end caps. So if I unselect this, detail, and go to the detail tab, there's an option here called end caps. And if I turn that on, now you can see that the cylinder is a closed cylinder, right? Now the orientation of this, you're like, okay, I want to rotate it by 90 degrees along the z-axis. I think you can do it that way. That's one way of doing it. But there's an easier way of doing it, and that's just to change the orientation here from y-axis, which is the default, to x-axis. And then that will change where the origin of this shape is, such that it's facing this way instead of facing this way. Right? Okay. So now we have a tube. We're going to need 3 of these, but for now, let's build one of them, get it looking the way we want, and then copy that instead of having to have 3 of them and add a whole bunch of extra objects in there. So first thing we want to do is turn this tube into a dial that has, we're going to start with numbers. So I didn't provide numbers, I only provided the symbols. But we can create our own numbers inside Touch Designer using a text object. So if you go in here and you add a text top. So what's the difference between a SOP and a top? SOP is a surface operator, and it's 3-dimensional data. It's basically data about vertices, about where vertices are, and how you can draw that into a 3D object. And that's why it's called a surface operator. It's describing a surface. And top, while they can both create visuals, a top is a texture operator, which is a 2-dimensional picture, right? So we're going to create text, which is basically a 2-dimensional picture as well. It's just in a particular format that we can recognize as characters on a screen, right? Text. So this is creating a texture based on text. And by default, they give you the word derivative, which is the company that makes Touch Designer. We almost never want that to be the text. So just pull that out. What we're going to want to do is we're going to want this to be black numbers on a white cylinder. And by default, the font color, as you saw, was white. So we need to, on Color tab here, change this font color. Change that to black. You can just pick it out of the swatch here. It's the easiest way. So now it's black text. It's black text on a transparent background. So like if I put in here 1, 2, 3, 4, 5, you can see black text on a transparent background. We actually want that to be a white background. So go back to color and change the background color here to white. And say OK. And you're like, wait, where's my white background? It's because the alpha for that color is turned down. You can see background alpha 0. Does anybody not know what alpha is? Okay, so an alpha channel, so colors are actually composed of 4 different channels. The main 3 channels are red, green, and blue. So if something was a red color, it would have 0. It would have 1 in the red channel. It would have 0 in the green channel and 0 in the blue channel. And then if it wasn't transparent, it would have a 1 in the alpha channel. If it was half transparent, it would have a 0.5 in the alpha channel. Make sense?
Yep.
Cool. Yes.
Please my text in the derivative thing as well as anything else I tested. I think the text box is not loaded. It's weird. It's like
Let me take a look real quick.
I think
Sounds like a bug.
Maybe.
Oh, weird. Something is there.
I could just make another operator and that.
Yeah, try making a new operator. If that doesn't work, try closing, saving, closing Touch Designer, and reopening it. Because that seems like a bug.
It's really annoying.
So no?
Yeah, I think it's a bug.
Okay, so try saving it, closing Touch Designer, and then reopening it and see if that helps.
So do we want 1, 2, 3, 4, 5?
No, you don't have to. I was just doing that as a demonstration. And actually, if you think about it, we want the numbers to go vertically around the wheel. If I went horizontally like that, they would all be sideways when I put them on the wheel, right? And we don't want that. So we really want like 1 and then a new line 2 and then a new line 3 and a new line 4. The problem with that is under text here, they don't have the ability, it's one line here, and they don't have the ability easily to put things on different lines, right? You could probably do it with some Python coding, which it just got really mad at me. Let me turn that back to constant. But for our purposes, there's a way easier way to deal with this and to make it do what we want, and that is to, instead of hard coding or specifying, what do they call it? A constant. Instead of putting a constant of specific text here, we're gonna create a reference to a dat up here, and we're gonna put our text in the dat. How are you doing?
I had to restart the whole thing and it didn't save as well. Just another bug.
Oh,
I guess.
wow.
So
Okay.
I'm just gonna redo the whole thing.
Yeah. So luckily we're not that far along. So just drag in your slot machine, make a tube, and add a text. All right. So what we're going to do is add a dat. So make a dat here, a text dat, which is a dat is another family of operators, and that basically it's tabular data. It's data that is put in different cells, like an Excel spreadsheet. Text. So I have a text dat here, okay? And I can add things to this text dat by making the viewer active and putting the numbers here. So we're going to want it to actually go from 0 to 9. So put a 0, then do a carriage return, or enter, go down to the next line. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And if you couldn't do that, then it's because you didn't make your viewer active. So make sure you make your viewer active by hitting this in the corner. Yeah?
I'm sorry. It's just doing the same thing on my text box again.
Wow.
Maybe
it won't matter when you make the...
yeah, maybe it'll just go through.
Try making the text in your text dat.
Yeah.
And we'll try it that way and see what happens. Okay, so now on text here, on your text object, operator, I should say, we can fill in this field here called dat. We need to make a reference to this dat up here. And the name of the dat is what is currently listed right here, which is text2. I could name this whatever I wanted. I could name it wheel numbers or something. Actually, let me do it in camel caps. Wheel numbers. And now I could say the dat that I want to look at, and make sure you're not putting it in specification dat. That's for something else. But here, if I put in wheel numbers or text2 or whatever it's called, wheel numbers, then you can see that text shows up.
I put a space between real and numbers and that showed up as an underscore on my...
Then you'd have to make sure to put that underscore in there. But it's better just not to use a space and instead use the camel caps convention. Camel caps is where you usually, and it's a convention that programmers use a lot, especially in Python and C# and other things. You have your words without spaces but separated by a capital letter. So you start with a lowercase letter. So you see here where it says wheel with a lowercase and then the capital numbers. That's how you can separate words.
Oh, okay.
And it makes it a lot easier to deal with in the coding. Otherwise, you got to deal with that underscore, which is just will slow you down.
Then I'm gonna go down to my other...
Yeah, here, text 1, and you put in wheel numbers as the name of the DAT. Okay? So now we got these numbers, but look, they don't fit. They don't fit on the screen. And the reason why is because this text under the common tab here has a specific resolution. And that resolution is not, it's too wide. It's got all this extra space that we're not using on width, and it's not tall enough. So let's change the resolution here from 256 by 256 to 75 by 380. And now I have 1 through 8. Why did I do that in my notes? I think because I changed the font down a little bit in size. So now go back to the font tab and change the font from 30 to, I believe it was 22.5. If you make it lower than that, then there'll be a big gap between the 0 and the 9. I think you want it to be 22.5. I think that's what I remember it. Yeah. I don't have it in my notes, but I'm pretty sure that's what it was. 75 by 380. Okay. So now, in order to put this text on this tube SOP, we need to texture the surface operator. And in order to do that, we got to create a material. So you can't, without creating a material, there's no way of putting what do they call these again? There's no way to put a texture operator directly on a surface operator, but you can if you turn it into a texture. Now into a material. First thing you need to do is add a material, which is its own family called mat. And there's different types here. The one that I use the most often is called Phong, P-H-O-N-G. And that's named after a guy whose last name was Phong, who figured out how to do graphics coding to create this kind of surface. And a Phong surface kind of has some highlights to it. It's kind of shiny. It kind of looks like plastic, which I thought looked pretty good on this on the wheels, as made them look kind of realistic. And because it's these hot spots and stuff on this, they're all dynamically react to lighting in the room. So you can have lights that move around and those highlights will move, which makes it look a lot more three-dimensional, right? So when you create a Phong material, they give you a donut to show off that material. Why do they give you a donut? Because if they gave you a sphere, you might get confused between that and a circle or something. And when you flip around a sphere, it looks the same on all sides, whereas a donut or a torus looks different on every side. Plus, a torus, no matter which way it's directed, no matter which way it's pointing, even if it's pointing edge on at you, you can usually figure out what it is, right? Whereas a sphere, if the lighting isn't right on a sphere, it's hard to tell the difference between a sphere and a circle, right? And a cube, if it's right on edge, it's hard to tell the difference between a cube and a square. But a torus, almost always you can tell what a torus is, no matter what. So I think that's why they did that as the default shape. But we don't need, wait, do we? We do need, hold on. Okay, yeah, no. Oh, right, you can't change it anyway. They just use that as a preview object. All right, so what we want to do is now, yeah.
Question for the
Resolution for the numbers is 75 by 380.
And then which category was the fog in again?
Fong is a material, so it's a mat.
Okay. I guess I must have been selected on a dot or stop or top or something while I click tab for that.
Yeah, you can also get to this by double-clicking on your canvas.
Yeah.
And then you can either hit the tab key to go to the different tabs, or you can just click up at the top.
I have a little problem. I don't know what I read, that every object is now like in an active mode.
Okay. I don't remember the shortcut either, but you could probably just click on each one and take them out of active mode.
No, it's like everything is disappearing.
All right, hold on, let me look. What did you do?
I don't know.
Oh,
That's
I saw that.
something. All right, I'll keep this one. Okay. Visually, I saw.
I saw, yeah, I
It
saw
made
that.
the it made the
Like,
room it made the room.
I was like,
All right.
whoa. No, I see that. I saw that.
It wasn't like this before, right? Go into what's in your edit menu. It must be one of these buttons up here. I can't remember which one. Whoops. That's perform mode. Here's escape. Open palette browser now.
Yeah, did you try to save and close and reopen?
Yeah, I already did.
And it's still?
Yeah, maybe I'm gonna do another one. Well, that's really bye bye. I can't remember what. I know. I think I remember this happening. I don't remember what the shortcut is. And if you add a new thing, that is a new one.
Yeah, no, that's one I chose.
Yeah, but I did that before. I have no idea what it is. Yeah, try doing a Google search on all Touch Designer, all objects are viewer active, can't turn it off.
Damn, this
Sorry,
room.
new one? I'm gonna save that one because it's gonna waste it.
I have no idea what you did there. It's not something I vaguely remember. A shortcut that makes your objects viewer active, but I don't remember it doing it to all of yours and breaking everything. That's a little strange.
Oh, the shortcut key A will set for onset view active flag off all selected nodes.
Ah,
Select all press A.
yeah. Select all. Do a Command A or Control A, and then hit the A key. All right. So we are creating a Phong texture with these numbers on it. And to do that, it's pretty simple. All we have to do, make the viewer active on the text top here and drag it. Maybe you don't make the viewer active. don't make the viewer active, and drag it onto the Fong material, and you'll see a little arrow with a plus underneath it. And then go ahead and let go, and now it'll say, what do you want to do? Do you want to do normal map, diffuse map, specular map? We actually want to do color map, the first one here. And then it creates a texture. Now, the texture here is a little strange looking. We want it to be numbers around the circle right now, and right now it's vertically. So we actually want to take this the way it is, but rotate it 90 degrees. And you're like, okay, how do I rotate it? Where's the XYZ rotation? Nope. No. We want to edit it before it goes to the Fong.
Oh, okay.
And there's no way to rotate this in the text object. I think that's kind of stupid. I think they should add that function. But there is an object that can do it for us, and it's called flip. So on the tops, the texture operators, find the flip, and if you start typing something, it'll highlight things that have those letters in them, which will help you find it in the big long list of operators. So add a flip here, and you can repatch from the Fong to the flip. Sorry, from the text 1 into the flip. And then what we want to do is we want to flip X, which creates like a mirror image of it. And then down here at the bottom, there's a thing called flop, and it's set to no flop. Change that to bottom left. And then it rotates it on its side. Okay, and now do the same thing you did with this text 1. Do it again to the Fong. So drag the flopped version, the flip version, onto the Fong and choose color map. And there we go. Now it's going around like a clock around the donut, which is the way we want to have it set up in order to...
Should it be on the outside rim, though? Like
You would
on
think
the
so,
top
but this is the way that it works for... This is like a torus, and we're doing it to a cylinder. And the way that they're UV mapped, doing it this way makes it line up correctly on the cylinder. All right, so now we're almost there. We have our material now called Fong1, which we could, if we wanted to, rename. I'm not going to, but you could put whatever text you wanted here. It's just as long as what you're trying to reference it, you use that text. We won't have that many Fongs, so I'm just going to leave it as Fong1. And what we want to do now is, in order to create a to texture this SOP, is we want to add a material SOP. So if you either double click and create a material SOP and then connect it to your tube 1 from the output of the tube 1, or even easier, you right click on the output of the tube 1 and then select your material.
What's it called?
Material SOP.
Oh, material.
And then it asks you on this material SOP what material you want to use, and you can type in Fong1. And now you can see it's created this material, this textured tube here with numbers on it.
I'm getting the red X on mine, and I typed in Fong1.
Did you change the name of Fong1?
Hold on, no, for just some reason it was not connected.
Yeah, once you get that association working, you'll see it draws a little arrow between your Fong1 and the material, showing you that association between the operators. Okay? Is anybody else having any issues? How are you? Did we able to unlock your?
I'm starting again.
Oh.
I'm doing that.
All right. Don't hit random keys, I guess. All right. Well, that reminds me. This is a good time to save. So go ahead and make sure you save your slot machine. All right. So Now we're going to want to be able to rotate our wheel. And there's a couple different ways you could do it. You could go into your original tube here and put a rotation on it. And if I wanted it to rotate this way, there's 3 types of rotations. There's X rotations, Y rotations, and Z rotations. And you can figure out which one you want by imagining an axle through the 3D object on the axis that you're talking about, whether that be the x-axis. If there was an axle on the tube this way, which way would it rotate? The way we want, right? If you put an axle on it this way, it would rotate like this, right? And if you want it to spin like the dial on a clock, the axis would be on the Z. The axle would be on the Z-axis, and then it would spin like this. But because of the orientation we have, we want it to actually spin around the x-axis. So here on rotate, if I wanted to, I could put like a 75-degree rotation, and you can see it's rotated now, and now the 0 is facing us. I don't know why the 2 ended up facing us by default. That's just kind of the way the textures worked out. But we can, when we write the code to make this thing spin, we can adjust for that 2 offset by figuring out how many degrees to add to the current rotation. So that's one way you could do it. But there's a much easier way, especially because this is just the rotation of this tube. Now what if, I mean, in our case, you could probably do it this way just as easy as any other way because we only have one object. But what if you had this wheel plus like little rims around it or little like lines that you've rendered, and you want all of those to move as a one unit? You would either have to send values to every single thing individually, which would be really annoying and might not work every time, and then you'd end up with some things rotating and other things not. Or you can put them inside of a geometry component and then spin the geometry component, which is way easier to deal with. So that's what we're going to do for this. And also, the added benefit is once we have that geometry component and it's working the way we want, we can copy that 3 times and we'll get 3 wheels with all of the stuff inside that we need to get the texture on it, right? So it's a good way to contain all of this stuff. All right, so let's create a comp, a geometry comp. Whoops, geometry, there it is. Okay, and let's call this wheel 1.
Should it be in between?
Doesn't matter where you have it right now. We're going to put all this stuff inside of it, so we'll have a lot of screen real estate in a second. Okay, so when you create a geometry comp, they give you a torus. We don't want that torus. We can pretty much all comps, I think all comps, you can dive inside them, and there's other things inside them, right? That's why when there was a slider, that was a comp. You could dive inside the slider and change the parameters of the slider and stuff. If you dive inside of a geometry comp, there's a geometry, there's a torus. We don't want that torus. Get rid of it. Dive out, and we have an empty comp. What we want to do is actually take all of everything but the slot machine. We want everything but the slot machine. So, and we want to cut that and paste it inside of our wheel 1 geometry comp. So the way you can select multiple things is make sure you click on one item first so that it's highlighted. Otherwise, you might have something highlighted that you didn't mean to have highlighted. Then hold down the Shift key and draw a box around everything else that you want highlighted. Don't highlight, whoops, I somehow highlighted the slot machine. So I'm going to unselect the slot machine by holding down Command or Control and clicking on just the slot machine. So make sure you have the one that you have main selected, which is outlined in green, and everything else except for the slot machine and except for the wheel 1 highlighted in yellow, right? So that is just this stuff. That's not the slot machine. That's not the comp. And then Control cut or Command cut, Command C. That didn't work. Command X, I mean. And then dive inside the geometry comp or double click on it to get inside of it and then paste it. Okay? Now you can dive out and you would think that you'd see your wheel there, but you don't. Does anybody know why? Render flag. I think that was in the video for the first week. So there's a display and render flag that you need to set. Display makes you be able to see it inside of the editor. Render makes you actually be able to see it when you go into perform mode. So these are the flags down in the corner. There's a purple one, which is your render flag, and there's a blue one, which is your display flag. You need to set that on whatever you want to have seen. In this case, our most downstream object, the one we actually want to see, is the material 1 SOP. And now when I dive out, I can see the wheel 1,
So you
right?
mean the render or the display?
Both.
Okay.
On wheel 1. I'm sorry, on the material 1 in here, if you turn these on. You don't want to necessarily have it on things that you don't need to render or see, because that's just going to slow down your performance.
So for some reason, my numbers didn't come over.
Yeah, me too.
What numbers?
The numbers of the wheel.
Uh-huh. Okay, so then let's take a look. Going back inside. What happened with your material?
When I turned on the display and the render, I got.
Is this okay? So don't turn off the render and display flag on the cylinder, and just have it on the material. Now dive out.
Oh.
Ah,
Okay, because what happened was you were rendering two things, and one of them ended up on top of each other. Yes.
My render ended up as a wireframe that I can't seem to undo here.
Oh, what is that?
mine seemed to be linked to the material and the.
There's a thing called okay. So if you right click on what's the thing that's wireframed?
It's the actual
Material 1.
No, it's the actual like full render on the mill.
All right, let me take a look.
That's why I thought I could go.
Yeah. Okay, so wait. Okay, so go inside that. All right, which one is wireframing this? All of them?
No.
None of them.
Does anyone else have a cover?
All right, go back out then. All right, right click on this. Nothing.
If you guys are having
Go
trouble
to-
seeing it, you might want to put it into a null at the end.
Display options,
Mine worked
Oh
actually.
wait, of course.
and then change it to from wireframe to.
Always good to have.
That's one of those.
Yeah, this is thank you. This is what I need to want to do. So, what is the one?
You have right here you have wireframe selected. Unselect that.
Oh,
Is it
so
like
that's origin.
So this right here I believe is the
its
wireframe.
shape was like
Unselect that.
an object
Is that
going
alright?
into a
Hit W.
material instead
I was
of
doing
like
W.
material
Maybe it has to be on.
It was just the way it works. If
Yeah,
you have a
W just
material which
increases
is on that
the-
sometimes it's
What
like
happened
a
there?
compositing difference with materials, so it's taking one material and
Because it looks right here.
Also, your material operator is just like
So everything's
putting the two things together. It's like sort of
And your text still looks all
composite,
weird.
like the
Yes,
composite.
that's a good
But
artifact.
it's not necessarily
So it's
ordered
okay.
alphabetical.
Wait a second. Go. This one is wireframe.
Oh, are you sure?
No, they're not. It's just your weird looking text. Scroll out again. I'm pretty sure it's in that display option somewhere. Something in there that where you can turn off wireframe. Origin. No, that's not it. It's what's under viewport? No, it's under that first tab. Point numbers, UV, point texture, primitive hulls, maybe. Let me look at what mine is and I can tell you what,
Okay.
we can see what's going on, what it's supposed to be. Zap, all right.
It's on beautiful.
Uh, I feel like there was a shortcut like W or something that turned on
That's what I've been using.
for wireframe, and I'm not sure. I can't remember off the top of my head where you turn that on and off.
That makes sense because I was using it earlier, the W function.
Yeah,
So maybe it got stuck.
yeah. Points. Okay, so I definitely can make it show me points. I can make it show me numbers, normals. UV doesn't seem to be doing anything. XYZ makes it do things. Let's see. Yeah, I don't know.
Maybe if I click undo and get a new view.
Maybe. I don't remember. Do a quick Google search on turning on and off wireframes. I can't remember. I'm sure there was there. I'm pretty sure there's a shortcut for it.
It's W.
Yeah.
Oh, suddenly, okay, this is weird. I just changed some of the display options and now it works, but it's not displaying my numbers.
Okay. Well, then it's probably just that you have your display or render flag turned on the cylinder and not on the texture.
On the material.
On the material. So make sure.
It's on material, definitely.
But is it also on tube?
They're
No.
having the same problem. They put it into a null.
Oh.
On the you send a null SOP.
My mystery
Yeah.
was just solved.
All right. So let's do that. Let's do that. Everybody, let's go ahead. Go back inside your wheel component, and after material here, create a null SOP. And it's best practices to have, no matter what it is, whether it's a SOP or a top or a DAT or a CHOP, to have a null object as your furthest downstream object. The reason is it avoids some of those weird errors, and also you can add objects in between this and change it without having to go back and change all of your references. Because if you make a reference to this material here, and then you want to add something downstream of that, then every place where you've made that reference, you got to change it to something else. Whereas if you made a reference to this null, and you always kept that null as your furthest downstream object, and you can add everything you want in between these two things, and you won't have to re-specify on all your objects that are making that reference, right? So you can turn off the display and render flags on your material, and instead turn them on for this furthest downstream null. Okay? And it should have the same effect. Now that we have this wheel in a geometry component, we can rotate everything inside that by sending rotations to this to the geometry parameters here. So like if I wanted to have a 45-degree rotation, I can put a 45 in here and it will rotate at 45 degrees. Okay, but what we want to do here is create the ability. Let's do something really quick. Let's create another geometry component. Let's go ahead and set up this for rendering so that we can actually see our wheels and our slot machine in the same screen. So create a new geometry component. Name this one slot machine. Okay, I did mine in camel cap, starting with a lowercase. Go inside, get rid of the torus, we don't want it. Grab your slot machine object and cut it. Go inside and paste it.
That was a lot really fast. Sorry, should I just rename I think slot machine and I go inside which one?
So you had your slot machine object here on the. You're going to put it inside of the slot machine geometry component. So cut it from here.
Do I have to go in and erase the torus?
Yes. Erase the torus. Grab this slot machine object here and cut it and move it into your slot machine geometry component and turn on the display and render flag for this object. So you should see it in your geometry component now. So now we just have two geometry components sitting in our editor. Makes it really nice and neat. So what do you guys remember from the previous classes that I wasn't here, but you guys watched the videos for? What are the objects you need to render something in perform mode? Yeah, lights, camera, and geometry. So we got geometry. We have two different geometries here, and that's fine. You can have as many as you want. And we just need a light and a camera, and then a render. So a light.
Mine's still not working properly.
All right.
Because I think I did the copy and paste and it put it in there, but I think I was.
You just have to turn on the geometry and render flag. I'm sorry, the render and the display flag. And now, so we have a light. We need a camera.
Was it all inside the geometry?
Yeah, we moved the slot machine inside of the geometry, that new geometry. But we want just the wheel in this geometry and just the slot machine in a different geometry, right? So then we have a light, a camera, and we still need a render top. Top, render. And when you do that, it'll draw lines between all of your geometry, your light, and your camera, showing you that it's rendering it. And if you look closely, it'll give you a preview of what it's going to render. And you can see this wheel is way too big, but we'll fix that in a minute. Now, if we go into perform mode, we would expect to see what we see here in the render, but we don't. Because you need an out. Yes, that's correct.
See, I need a render top.
Yeah, render top. And then we need an output. So coming out of the render top, you can right click on this output and choose an out. And then if you go into perform mode, you should actually see these stuff. And if you hit escape, you can get out of perform mode. It's a render. It's a top out, an out top, and attach that to the render. Yep, out top. Because it's a texture operator. Because you're outputting a two-dimensional image. It's a two-dimensional image of three-dimensional objects, but it's still a two-dimensional image. We don't have a holographic display that we're sending this to, right? What? If you right-click on your render's output. There's ins and outs for comps. There's ins and outs for DATs. It's for when you create, and we may or may not, depending on how time is going, get to that later today. We're going to have a container with some math objects in there, some chops, and there'll be an in chop and an out chop to send data into it and send data out. And the container in that case, it's just a way of containing your code so that your main editor is not full of a bunch of stuff. Right?
That's kind of putting everything inside of the geometry.
Is to keep it nice and neat and keeping things that do the same sort of thing or establish. You don't need that yet. Don't worry about it. We'll get to that later. We need to get this wheel sized correctly and get it spinning correctly first. Okay. How are we doing?
I have a general question.
Yeah.
Does the composition work as like a canvas?
Which comp?
I mean, just like comp.
Any of them? Yeah. So it's like its own like sub canvas, right? So most I think all comps you can go inside of them and there's a new canvas inside of there that you can put other things, right? Some comps are already set up for you to do specific things, like a slider, for example, which we're going to need anyway, so go ahead and make a slider comp. Right? This if you go inside of it, you can see here is an out. This is a chop, an out chop. And that's why when you go out of this slider, there's a green output here because there's an out chop inside of that comp component, right? And you know it's a chop because it's green. If this had an out sop, it would have a blue thing over here. If it was an out top, it would have a purple thing over here, right? So we have our slider here. We're going to use this just to make this wheel spin temporarily. Should we size it to match the slot machine first, or do we just want to make it spin as is and then resize it? It's up to you guys. Do you want to make it spin, or do you want to make it fit inside the slot machine first? How many wanted to fit inside the slot machine? How many of you just wanted to spin first? Oh gosh. All right, we're going to make it spin first. It was like exactly half and half. All right. Yeah, let's make it spin first, and then we'll make it fit inside. All right, because it's easier to see right now anyway. All right, so what we're going to do is, if you look at this slider, you've all created a slider, yes? Great. Create a null chop on the output of the slider. That didn't work. There we go. Null. Just so you can see what this slider is outputting, go ahead and make your viewer active on your slider and drag it from left to right. You can see that it creates a number, a floating point number that goes from 0 on the far left to 1 on the far right. Now we can send that to the wheel's rotation, but how far do you think it would rotate with a number going from 0 to 1? It would rotate between 0 and 1 degree, right? So like that far, right? So that's not going to work. So we could change this sliders out parameters. There's a thing in slider where I believe, let's see, what is it? Is there a thing in sliders? Slider parameter? Yeah, there isn't even one, because they expect you to do it a different way anyway. And that is to send it to, we could use a math object to do some ranging. And what do you think we'd want to do if we wanted this slider to make the thing spin the entire way around? Yeah, but how would you do that if you're arranging it? So let's go ahead and add, coming out of this slider, let's add a math object, a math chop. So, and then if you add a math chop, and then you go to the range tab, it'll say, okay, your from range is 0 to 1, which is what our slider is giving us, and our to range, what do you think we'd want that to go to make it spin an entire 360, right? And that's cool. We can do that. Let's do that really quick. We're going to end up changing it, but for now, let's go ahead and do that. So go from 0 to 1 and remap that to 0 to 360. And that totally works. Well, we haven't connected it yet. Let's go ahead and connect it. So to get this wheel here, actually, let me move it to the other side, move this stuff to the other side of my component over here, like that. All right, so to map this null output to the rotation of our wheel here, you guys remember how you can make that association? So we are wanting it to go to rotate, I mean. Right now I put an arbitrary 45-degree rotation. You guys might have a 0 in there. That's fine. We can, one easy way is to make your viewer active on the null here and drag it onto the rotate X field. And you can just say export chop. We're going to actually end up doing some math to this, so we want to actually do chop reference. They both would work the same way, though. It's just chop reference creates a Python reference, which then we can add extra math to and do more fancy things. If I just exported the chop, it would only give me whatever the value in the chop is. It wouldn't let you do extra math to it, which we're going to end up doing. So this would totally work, but it's not set up the way we want it. And look, if I move the slider, it's giving me, it's making the wheel rotate.
But it's getting smaller.
Oh, so there is kind of a gap here in between my 9 and my 0. What was the font size that I needed to do to make that not happen? Let me go inside my wheel really quick. And I think this text font size is, instead of 22.5, let's try 23. I think maybe Sai was right. Yeah, that looks better. Yes, question.
Is it a normal thing that, like, when you scroll down the number and the scale also changes?
The scale changes.
It's like, but I don't know if that's it.
Oh yeah, yes, it does that. It just moves it a little bit. That is just the display of the object in your editor. That has nothing to do with what's actually rendered. Okay. So I changed the font size on the wheel here. This text font size to 23, and that made it, the gap between 9 and 0, much smaller, and made it look better in my opinion. It won't actually matter. It's more of a visual thing. But if we don't get it right, then the numbers won't quite line up with where they should be. The slot machine would still work, but it wouldn't look as good, right? So this works, but the thing is we actually are going to be analyzing. We're not going to be analyzing 36 degrees. We're not going to be analyzing 72 degrees. We're going to be analyzing numbers 0 through 10, right? Or sorry, 0 through 9, or 10 different numbers there, right? So instead of having this slider go between 0 and 360, let's instead make it go between 0 and 10. Or 0 and 9. 0 and 9, right? Let me see. I feel like, but then we're going to do some math to change that into, no, make it into 0 to 10. I'm almost positive about this. So make it go between 0 and 10. So it's 0 on the far left. It's 10 on the far right. We're not going to actually ever get to 10 because it'll roll back to 0 before it gets to 10. But we need that space between above 9 so that it doesn't hop straight from 9 straight to 0. That's why it goes from 0 to 10. So now we have this number going from 0 to 10. We've sent that to a reference here on our geometry. And if you see how it says this number here is blue, that's because it's a Python relative reference. If you expand that by hitting the plus here, you can see the actual Python code that that creates this reference. And it is pointing to op null1. These are all operators. So when you reference them in Python, it'll always start op, then open parentheses, and then a single quote and the name of the operator, whatever name you've given it. This is just the default name, which is null1. We could change that to the word banana and put banana here if we wanted to. Let's not, but you could.
Mine seems to be working, and all that's in there when I dragged the null one into the wheel was, it's just.
You did a chop reference. You need to do a relative reference. Relative.
Export.
Yeah, so that's the wrong thing. So drag it in again and change it to chop reference instead of chop export. Otherwise, you won't be able to add the math that we're about to add. All right? So this is, so there's a couple things. This is a Python reference to an operator in Touch Designer. This is the name of the operator, null1, right? And where do I stand? And then after that, you're either going to be referring to values of some sort. Those values may be, especially in chops, they may be a channel, which is going to give you numbers that are changing, or they may be parameters, like you're going to be sending something to change its parameters, like change its font color or change where the what the timer value is going to be. that is going to be if it's a parameter, it'll be this op null, and then it'll be a dot par dot whatever the name of the parameter is, and then you'll set a value there. If it's a channel, it'll have an open bracket and then either the name of the channel, which is in this case is V1, and we know that because right here, this is the actual value, and then next to that is a V1. That's the name of the channel. So you can either reference that channel by its name, which is V1, or even easier in our case and makes it way more reproducible, you can reference it by an index number. So this is the first channel's name is V1, and that's what they gave us by default. But instead of referring to it by name, we can refer to it without any single quotes here by its index number, which is the first one is 0, and that will give us the same value. If we had 2 channels, the second one would be 1. If we had 3 channels, the third one would be 2. You know, so it's like counting from 0. So 0, 1, 2, 3, 4, 5.
So I've got my op, and then parentheses, I got my null one, in brackets, I got my V1.
Yeah, so
and then
take
after
out
that-
V1 and change it to a 0 without any single quotes.
Okay,
And the reason why
just
we're doing that
brackets.
is that way we can paste this code other places and we don't have to change that name,
Got it.
right? Because we're just using an index value. We're just caring about the first channel here. We don't care what its name is. Okay? So we've done that. So now we have a reference that goes between 0 and 10, but we want to use math to create a rotation that goes between 0 and 36. Sorry, 360. So what could we do to a number that goes between 0 and 10 to transform into a degree value that goes between 0 and 360? Bingo, multiply it by 36. So just say times 36. Okay? Now we can drag this and it goes from 2. Actually, here, now that we set this up for rendering, I'm all zoomed in. I'm zoomed in with my, what am I doing here? Oh, now I zoomed out too far. There we go. You can hit this thing over here, which will open a window, a viewer window. It won't go into render mode, but it'll open a viewer window, which you can resize, which is really handy for like seeing how it's going to be.
You mean perform mode?
No, in perform mode without going into perform mode. It's a viewer. It's right here, this little square, open viewer. Hit that. If you don't see anything in your viewer, then you still need to set up your out here on your render and stuff. All right, so this will make it way easier to see what's going on. So now we have this wheel that spins. We got about 10 minutes left in class. We're doing okay. I thought we wouldn't get as far as I have in notes, but we're getting as far as I think we got last year, which is fine. So you'll notice here that it goes from 2 at 0 all the way up to 2 at 10, right? Wouldn't it be nice if 2 was 2, 0 was 0, and 9 was 9, right? How can we do that? Well, first of all, we can apply an offset here to take this back to 2, or take this back to 0. So what would I have to do to make this rotation be 0? So right now I have this rotation set by a expression, this blue flag here. I can change it back to a constant by clicking on this gray flag. It'll make your code disappear and you'll freak out. Oh my God, I just spent 10 minutes figuring out how to write that code. It's still there. You can click on the expression tab and flag and it's still there. But you can temporarily override it by clicking on the constant. And now I can try to figure out what rotation I need to set this back to 0. So let's see. What if I had a negative 30 degrees? No, that went the wrong way. Okay, so let's say positive 30 degrees. Oh, that's 1. All right. Let's try, yeah, he said 72. Let's try that. That looks pretty good. All right. So 72 degrees, adding 72 degrees to it will make it 0 be 0. So let's go ahead, go back into your expression here. How would I add 72 degrees to this? But do you really need parentheses? There's a thing called order of operation. Remember PEMDAS? You probably learned it in grade school. Parentheses, exponents, multiplication, addition, multiplication, division, addition, subtraction in that order. It's going to do the multiplication first and then do the addition. So we can say plus 72. And now it's at 0. Now, go ahead and try and slide it. Uh-oh. It's kind of working, but look, when I go to 1, if I look over here on my null to see what value I'm currently on, if I slide this so that that null is at 1, I'm at 9. So the wheel is actually rotating the wrong direction. So how do you think I could adjust for that? Boom, she got it. Amy got it. So we're multiplying by 36. We can just as easily multiply by negative 36. And now 1 is 1. And 2 is 2. And 7 is 7. All right? Yeah.
9 is almost 9.
Well, it depends on whether you fix that font size thing. If it's starting to get drift off, then we got to fix that font size thing.
It's just as drifted off as the 0 is, so it's...
Okay.
You fix the font size in the material.
It's inside of the wheel component in the text here. There's a font.
That's right, yeah.
We have it as 23. I'll go back and check my video and see. Actually, let me save this and open up that other version, and I can tell you what it should have been. Let's see. Class 3. So I figured this out last year. I didn't put it in my notes.
Font size actually put in 22.5.
Yeah, that's what we started, but I don't think that was right. But let me check my version from last year, and I can tell you what we had it. We had it working really good last year, so I should be able to tell you what font size that was. Takes a long time to load because it's a big program. All right, here we go. Wheel. Looks like I called it. Yes, come on. There we go. I guess I called it spinner back then. No, I didn't. It's here. Wheel post, that goes to a math object. Where's my actual wheels? Oh, there they are. Wheel 1. Oh, shoot. This is where I changed it to this. Do I still have the text? Oh, I do still have the text. Okay, great. It's not attached to anything, but it's still here. All right, so font size is 22.5. You called it. All right, fine. 22.5. 22.5. So change the font size to 22.5. Come on. Don't try and copy what's on this screen right now. It's not. This is way further ahead than we're going to get today in the next 4 minutes. Yes, questions?
Are you able, or am I just blanking here? Like, are you able to share the actual project files or on the email or something on the website, so we can actually open these files and see the actual inner workings?
Yes and no. I'm not sure. Yes, of course I'm able to share them. I'm not sure I want to yet because I want you guys to do things as homework, and I don't want you to get the answers before ahead of time.
Yeah, exactly.
So eventually, yes, they'll be up there,
Yeah.
and yeah. But suffice it to say, your homework for next week doesn't have to do with this. Like, we're going to continue working on this, but your homework is going to be basically the interface stuff that we should have gotten to last week.
The watching of the video.
Yeah, watching of the videos and making that little demonstration patch like I showed you what Cy did. Right? All right, so we have 3 minutes. Let's fix this text size thing. So it's 22.5 font size, 22.5. Okay, so cool. We got a number here. And if I move the slider to 9, 8.99 is close enough. Yeah, that's pretty much centered on that 9 symbol. Okay? Cool. Is there anything we have time enough to do else? We got that. Question? What? Change the size. Yeah, maybe we can stuff it inside of the slot machine really quick. All right, so the first thing we want to do is see the, so if I were to turn off rendering on this wheel by clicking the render flag, you see it disappears from the render. And if I'm looking at my viewer here, first thing we're going to want to do is move this slot machine. See how it's up halfway? It's up too high, right? So let's move the slot machine down. So all we have to do here is on the slot machine geometry component, on the translate, on the Y, move that down by 1 unit, -1. And that puts the slot machine pretty centered. All right, so now that we got the slot machine more or less centered where we want it, we can move the camera in closer to it so that, translate that by -1. Move the camera in closer to it, and we're going to create a null target for the camera to actually look at. So move the camera closer here on camera. What did I move the camera to? I moved the camera to 0.3, 0.3, and 1. So on translate here. So it's going to move it a little bit. No, sorry, 0.03. It's going to move it a little bit to the left. And then 0.3. And then instead of 5 on the Z scale, 1 on the Z scale. 0.03, 0.3, and 1. We're going to, maybe I rescaled the thing. Let me see, hold on.
If you do 0.03 for both the X and Y, then I get all the
That's what it was. I just wrote it down wrong in my notes, so she's right. So instead of translating 0.3 on the Y, translate 0.03, 0.03, and 1. That puts it fairly centered on the dials. Yeah? And now let's create a look at. So even if we accidentally move the camera, it'll still be looking at the right place. And let's create a target for it to look at. And so you can create a null component here. So I'm creating a comp called null. And the only purpose of this null component is to provide a fixed reference point at 0, 0, 0. Actually, no. We're going to put that as 0.03. Oh, okay. So name this null2. Rename it to camera target or cam target. Cam target. And the values that I had for that to kind of even adjust this even better was to put this at 0.03, translation, 0.03, 0.07, and leave the Z at 0. And now on your camera, you're going to put a look at, you're going to specify that cam target as your look at. So you see those fields that says look at? I can put in cam target here. It's,
I do, yes.
yeah. And see how that just slightly adjusts the field of view of the camera there?
Yellow. I got a warning.
Then you probably typed your whatever your target you typed is not quite what you set its name as.
It says I'm able to calculate look at the up vector parameter is likely parallel to the look at direction.
That's what it says on mine too.
Wait, what did you set the look at? Did you set the look at inside your cam target? Or did you set it inside your camera? You need to set it inside your camera, not your cam target.
Oh, thank you.
Yeah.
I can do that. I'm still not getting the thing. So
All right.
I'm in cam.
Well, anyway, we're over time. we can fix that, or if you can stick around for a couple minutes, I can help you fix that. Let me just reiterate what the homework is for next week. So the homework for next week is right here on the website. It's go to these YouTube, watch these YouTube tutorials and patch along with Matthew Ragon. This button customization, horizontal slider, vertical slider, 2D slider, and slider with float feedback. He's using an earlier version of Touch Designer that has some of the parameters are in different tabs than the current version. So the ones that you can't find when you're trying to patch along with him, they're still there. They're just in the Look tab. Okay. So you can find those parameters in the Look tab. Just feel free to pause his video and rewind if you need to, or the Children tab. So do those, and then create a little. So do that. Then this is the main homework assignment. Create a network that has a horizontal slider, a vertical slider, and at least 2 buttons. And if you want to do a 2D slider, that would be great. You don't have to. And then make sure all of those objects do something. So you can use them to move your camera's position left and right. You can use them to move an object up and down. You can use the buttons to trigger some code. We didn't actually get to the chop exec this week, but there's plenty of things you can use those buttons. Those buttons make a 0 and 1. So you could make that camera rotate upside down, or or you can make the object change colors or something like that, right? Just make the buttons do something, and then create a video of it and put the video on your blog, okay? If you have any questions or that is too hard for you and you want a little bit of help, feel free to email me. Let's set up a time and I can help you with whatever you're having trouble with. I know we're a little bit behind because I wasn't here for 3 weeks, so I'm really open to helping you guys out, and I'm always really open to helping you guys out, okay? I don't want anybody feeling like they're struggling and are falling behind and struggling to stay above water. Please come see me. I'm here almost every day of the week, and I can work around your schedules because I'm staff here, so I'm always here. All right?
Thank you so much.
Yeah.
Roxana,
Yes.
do you have a display problem over here?